Hi everyone, this is Miriam Naime from Newcastle University and the Alan Turing Institute. Welcome to our SuperGen Smart Charging webinar series. The webinar is an activity of the Vehicle Grid Integration Group at the Alan Turing Institute. The Turing is the national institute in the UK for data science and artificial intelligence. And one of the activities of the institute is to apply data science methods to real-world problems, such as what we are doing at the Vehicle Grid Integration Group, where we are supporting the decarbonization of transport and electricity infrastructure. On the webinar, we already had speakers who discussed regional and national plans for the rollout of charging infrastructure for electric vehicles. We also had topics on cybersecurity, such as the proposed architecture for a public key infrastructure for electric vehicle charging. And we also had talks on communication protocols for the electric vehicle ecosystem, such as OCPP, ISO 15118, EE-bus, and so on. And today, I'm very happy to have Casto Cañavate and Joost Demarest from the KNX Association to talk to us about this protocol and what it can do in the context of e-mobility. So without further ado, Casto, Joost, over to you.
Good afternoon, everyone. I will be starting the presentation. My name is Casto Cañavate. Indeed, originally I'm from Spain, and then I'm working at the marketing department of KNX Association. So I will start sharing share the screen. Okay. Just trying to look for the right screen. So you can see the presentation already on screen?
Yes, we can see it.
Very good. So as Miriam already mentioned, we are going to have a presentation today about how KNX sees or feels the gap of electrical vehicles charging in smart homes and smart buildings. That's the intention of this presentation. For this, myself, I will be giving some general information about how it is the market situation, how the industry is moving on, how are the European regulations. And then Joost Demarest, who is the CTO of KNX International, he will be giving the technical details of how to realize this application in particular. And to start the presentation, I want to give 3 important facts that we have in consideration, and they are very important. I know this webinar is for the University of Newcastle, and you're based, of course, in Newcastle. And this concrete slide that you can see here is about the European Commission. So I'm aware of Brexit, but still, what international governments are saying, what the European Commission strives for, have a net zero emissions for transport by 2050. This is a big change. This is not easy to achieve, but already impacts the life of today, because we need to make this transition that by 2050 we are able to reach this recommendation or regulation. And this is one direction by the European Commission, but it's not the only one already aiming for a change. When we look at the industry and we look at the different organizations, platforms that they are coming up to the market, it's amazing. For instance, we see this is a very well-known European platform, is the platform for electromobility, and then they really want to help in this change, in this transition, to have a full mobility based on electric, on EVs, electric mobility in general. What is very interesting here is they already estimate by 2030, only the sector of electromobility will create around, or like they show here on this slide, they will create 1 million jobs, European jobs, only in Europe by 2030. And what puzzles me actually is not only this, which is, okay, very interesting, so new opportunities for everyone who wants to work on this sector, but actually the cut on oil. So by 2030 will be if we move to electromobility, it will be a cut of it's an estimation of 1 billion 1 million euros in the use of oil of every day. So that's the saves. We are saving a lot of future emissions on CO2. And the last fact I want to mention is how the market is evolving. So this is this report is from Markets and Markets. In 2019, there was an estimation of over 3.2 million EVs, and so this is worldwide value. Okay, last year we have last year in 2020 we have the number grew to almost 9 million EVs, and if we look at the trend here, there is a very positive trend to grow still on the sector, up to reach the almost 27 million by 2030. And that's a very good indication that this market is just growing every year. And it's year by year, it's growing more and more. So these are the facts that I wanted to share in how the market is evolving and what is the future landscape of EVs. And now also how we live this in KNX. So KNX is a technology. We are now 31 years old. We started in 1990 to control applications in homes and buildings. This is what we do in KNX. With the years, we developed different ways of making the communication. So we started with twisted pair, our most common use, and then we extended with power line communication, radio frequency, and even IP. So we started communicating via IP already a long time ago. It was 2007, if I'm not mistaken. The year that we developed already communication over IP with KNX. However, in the last years, we've seen, so when we look at the past and we look at the scenario of today and the future, we moved from a lot of technologies using proprietary systems. So in the silos of different technologies. Today, silos are not really well accepted anymore. So we talk more in terms of ecosystems, that I will mention about it now. And the world is moving to digitalization. So of course the use of data is very important, and digitalization is making this possible. It's making possible that everything can move easily. So thanks to the digitalization, we move towards an IP-based world, which is actually what we aim in KNX. We are aiming to have also not only IP communication, but also cybersecure. And this brings to KNX the extension of the KNX specifications to have, on top of what we already did since 1990, to have on top of that an extension, and we created the KNX IoT specification. Thanks to the KNX IoT, this is the vehicle that enables the evolution for KNX, because now KNX will easily integrate the IP into the specification. We already have it, and it was done via what we call the KNX NetIP. Now we do it with KNX IoT. We are using a standard language, so it's not KNX specific anymore. And that helps to IT experts, because they don't need to learn specific languages. They can use a universal or standard language. That lowers the barriers, the entry barriers for IT experts to also enter into the world of KNX. And that was our very first step. And please do not forget, we are not getting rid of what we did in the past. KNX is a backward compatible technology, so every single development that we started in the very beginning has always been considered, so that integration with solutions and devices that they were developed in 1990, they can still be used today. And with KNX IoT, this is not an exception. So we expand the possibilities for KNX integration, and now we are able to integrate even more solutions, more possibilities into the KNX ecosystem. And why it is an ecosystem? Because KNX IoT has enabled also the possibility to bring what we call the services with KNX. Services with KNX is the opportunity to now integrate also third-party companies offering services to the smart homes and the smart buildings. And so now, thanks to the KNX IoT, we integrate into one installation, into one project. You can integrate any KNX device, and you can also integrate other devices, so the typical IoT devices. And the devices, they can do different functions. That was always possible with KNX, but now when we bring also these external IoT solutions into the KNX world, the possibilities are endless now. And this is what we bring with the services with KNX. Devices, they can do different functions. They all work as an ecosystem, and we can have this communication with external companies to make also agreements with them and to get services from these companies. A typical example could be, for instance, there is a good project of a KNX project having communication with Red Cross in Germany, and they communicate, so they monitor a smart home of elderly people living in the home, so that in case, imagine if someone would fall and he doesn't move in the corridor, so the Red Cross will get an alarm, so someone is staying there in the corridor, and they will call for safety reasons. So they will call to make sure that this person didn't fall, that it's just a tracker or just a movement sensor that didn't do, or that they detected something that wasn't there. And that prevents if they have problems, so they can be quickly assisted. So, and this is a service. It's an external service offered by Red Cross to a smart home in this particular house for an elderly family. That's what brings services with KNX. And then, just to finish from my side, there is a very special service with KNX, and this is the energy management. And this is very important because we consider energy management as the progression of energy efficiency, which was very much, it was very important in the past, but today energy management is a move forward, not only to make a very efficient use of energy itself, but also to make the world more sustainable. And this is where the aspect of energy management comes, or it fits very well to us. And as part of energy management, one of the applications that they became most developed is, as you can imagine, the subject that brings today this discussion. How is EV charging of electrical vehicles, how we can fit this into the story of KNX is because with the energy management, we can have direct communication, we can have direct charging of EVs in smart homes or smart buildings. And for now, that is what we can do. There are several ways. So imagine, for instance, a building has its own on the roof. For instance, they could have their electrical photovoltaic panel. So if they generate energy and it's your office where you're working during the day, you connect your electric cars to the charging station. So this building could offer you possibilities to charge the car while you are working. Or additionally, also possible that the building could communicate with external energy providers to supply energy if this is required for the workers. Just a couple of examples as I leave this here. And from my side, that's everything that I wanted to mention. I will now open the stage or give the time to Joost for more technical details about this application. And of course, if there are questions, you can ask me after he finishes in the Q&A session of this webinar.
Good afternoon, everybody. Hello, ladies and gentlemen. Also from my side, Joost Demarest speaking from KNX. A warm welcome to this conference. I will give you more detailed look on KNX and the topic e-mobility. This is the slide deck, or this is the content of what I have in store for you. Quite a lengthy list. I will not stay or dwell too much on this list, but go straight to business and I want to try and first of all give you some history on how KNX came about, and then also explain you a little bit about the technical details of KNX, and also already give you more insights into KNX IoT, already mentioned by Casto, before moving on to energy management and how KNX solves the exercise of energy management and e-mobility already today. Okay, so let's first look at the history of KNX. As Casto already pointed out, KNX has been around for more than 30 years. So we don't refer to KNX as 30 years old, but we prefer to say it's 30 years young, and it has 30 years of experience. And in this slide, you see the first companies that actually invented the idea of KNX back in the late 80s even, and decided to set up an association around this idea. And these companies invented the solution, which they called at that time still Instabus. And this group of manufacturers grew to well, a dozen manufacturers who joined together to found an association in Brussels called the EIB Association, the European Installation Bus Association. This was in 1992. A couple of years later, because of the fact that the market was already occupied with some other solutions in the area of home and building automation, it was decided to merge or to team together with two other associations dealing with this topic. This was on the one hand the Batibus Association, and the other association was named the EHS, European Home Systems Association. And together they decided to merge and to become what is called today KNX. So in 1997 to 2001, the so-called convergence process led to the founding of KNX. In the meanwhile, some more companies, smaller or bigger, joined the association, which in the meanwhile hosts more than 500 representatives from all over the globe, all interested in the idea of integrating the KNX protocol into their product and using it to communicate in installations and well, ensuring especially coherent installations and interoperable installations. You can find the latest overview of all the members of the KNX Association in the link provided in the left-hand corner. Yeah, KNX is not only a community of manufacturers, but in the meanwhile we have collected some other type of friends around us. Starting with the nearly 100,000 KNX partners in 171 countries. These partners are mostly electricians or integrators, actually installing the products of our members in smart homes and smart buildings. And these KNX partners are persons who have visited one of the 502 current certified training centers in 72 countries and have passed a standardized test to become a listed KNX partner. There is a dedicated website where you can look for KNX partners in your vicinity. We also cooperate with so-called scientific partners. These are universities or research centers or technical high schools where their students are taught about KNX in home or building automation courses. We have 21 user clubs around the world. These are mostly partners that come together on a regular basis to discuss, to exchange information about particular projects they solved with KNX. We have 45 national groups. I will come to that in a minute. We have also many cooperations with many other organizations, even with other protocol organizations like BACnet and Thread. We have 18 test labs accredited, and I will also come to that in a minute. So if you're looking for a face to KNX, we have a central organization in Brussels or near Brussels, consisting of, well, you see 17 faces. In the meanwhile, there are 19 faces in this association. And we have also 45 different countries where there is a local promotion activity called a KNX National Group Active. So also in China, you can address the local KNX China if you have any questions on the KNX protocol. Just 2 slides to give you an idea of where KNX is used. KNX is used in smart homes. I have picked here only a couple of pictures of projects that are handed in for the biannual KNX award. This is an award that is handed out every 2 years for the best projects realized with KNX in different categories. So these are typical residential projects and only concentrated on Germany. These are some residential and commercial projects realized with KNX worldwide. So be it Singapore, Auckland, Belgium, Ethiopia, you name it. KNX is used practically worldwide as a solution for integrating different applications in a home and a building. Yeah, what applications can be controlled by KNX? Well, you can, as a rule of thumb, you can say any type of application that is used in a home or a building can be connected to KNX or can exchange information via KNX to the network, to the home or building network. Be it lighting, be it audio, video, be it heating, ventilation, air conditioning, be it security, be it smart metering, be it sun shading. So anything controllable in a home or building could use KNX for that purpose. Of course, KNX comes traditionally from from applications that I have just pointed out. So HVAC, intelligent shading, ventilation, control of split units, even a connection of renewables like solar panels to via KNX. We also cover, as I already mentioned, smart metering. So there is a possibility to connect smart meters up to KNX. But of course, the world has evolved. I think Casto has shown that quite correctly. And more and more devices are have seen the light in homes and buildings, which can now also be controlled with KNX, be it traditional white good applications, be it, for instance, heat pumps, or even energy storage possibilities, and then also the topic of today, of course, also e-mobility. Well, one of the typical questions I always get, why does KNX stand out compared to the to other solutions that are on the market? Of course, we don't stick our head in the sand. Of course, there are millions of other technical solutions around, but why would I bet on this KNX horse instead of another solution? Well, first of all, KNX has always, from day one, we have always put a big emphasis on the second topic that is written here, seamless interoperability. I do know that this is often used, this interoperability, this word interoperability, but we have, because of the fourth topic that is mentioned in this slide, product certification, we oblige all manufacturers making KNX compatible products with a KNX trademark to prove that they comply to the KNX standard, and not to prove compliance to the KNX standard by simply issuing a declaration, but by actually proving this towards a third-party testing house. So that means that a manufacturer must, if he wants to brand the product with the KNX logo, must go to one of the KNX accredited test labs and submit his product there, and the test lab will issue a test report to us and to the manufacturer. And if this test report is positive, only then will the use of the KNX logo be confirmed. Casto has already mentioned it. We have a proven track record of not changing the protocol every other week. and creating incompatibilities. What is a philosophy of KNX is that we always build on top of what we have already laid down in the past. So there's no compatibility break since more than 30 years, and also KNX IoT will build upon what we have laid down in the last 30 years. Also very important, if you mix products from different manufacturers in a single smart home or smart building, then it is paramount that the way the products are linked to one another. So say you have a dimming sensor and you want to link that to a dimming actuator of two different brands, then these two different brands need to agree on common configuration procedures. And for that, we have laid down two different flavors of configuration modes. The first one is without a central tool. This is called easy installation. And this focuses on small scale installations. And we also have a tool-based approach for configuring products. This is especially intended for medium and large scale installations. I will give you some more insight into that. If we are talking about easy installation, then each device, so here this could be, for instance, a customer energy manager and, for instance, a charging station to which a car is connected. If both products would be KNX compliant, then both products would actually publish their possibilities on the network. So they would both, you would have to bring both into configuration mode, and then they would start the linking procedure, and then they would start telling what functionality they have. For the customer energy manager would say, hello, I'm a customer energy manager. And the other device would say, okay, I am a charging station. And the customer energy manager would say, okay, if you are such a device, I have this to offer. Would you have the same, would you have a corresponding output to my input? And then the charging station would reply positively to that, if it is, of course, a charging station. If it's something completely different, then the product would say, sorry, I have nothing to offer for you. So the linking is always done 2 by 2, and the devices negotiate amongst themselves without the help of a central intelligence whether they can link to each other or not. Another approach is complementary to this easy configuration possibility. So you also have products that, on top of this easy configuration, also provide a possibility to configure the products also with a central tool. And this central tool is a PC tool. And we also have a possibility that this is not installed on a PC, but on a tablet or another mobile device. The PC version is called the ETS Professional. The non-PC possibility is called the ETS Insight. So you should imagine this PC tool as a view on the building, where you have the different rooms and the different floors. And in these different floors and in these different rooms, you can actually insert devices. and these devices show their different functions, and these different functions can be linked to each other via this tool, be it on this PC or on this tablet. Yeah, a question which is also often raised is, yeah, well, how does what ensures this interoperability between these different products? So first of all, of course, maybe returning to the previous slide, KNX consists of the possibility to exchange data via a separate twisted pair network, via radio frequency signals, wireless, or via IP, already mentioned by Casto, called KNX Net IP. So the first thing that is of importance is, of course, that the product supports one of these media. The first possibility of the manufacturer is that he buys a chip which supports making signals on this particular medium. And there are certified solutions for that. So if the manufacturer uses such a certified solution, then from a certification point of view, we say, okay, we have already checked conformity of that. That is okay. The second thing on top of this medium compliance is that the product needs to comply to the protocol exchange mechanisms during runtime as well as configuration, and this needs to be realized on some microcontroller. If this microcontroller with this implementation of KNX has already proven to comply to certification, then we also say, okay, we know this type of realization, so also this compliance does not need to be checked again. And then, of course, every product needs an application, a specific application for the specific purpose. For instance, a dimming actuator has a different application than a charging station. That is logical, of course. But for these applications, KNX imposes the use of specific data formats. So if you make a temperature sensor, and if this temperature sensor sends out the current temperature in the room, then it must do so with a KNX standardized format. It may not do it differently if it wants to obtain certification. To check compliance of both the OSI layer compliance as well as the compliance to the specified formats of KNX, we have a specific tool which is called the EITT. And the EITT is used by manufacturers, but it's predominantly used by test labs to check the compliance to these requirements of the KNX standard. Yeah, the topic of security was mentioned. At the time of designing KNX, security was not a hot issue. Back in the 90s, this was not the main concern. But of course, security is an issue, and nobody wants its data to be available to just anybody, surely not to people with bad intentions. And that's why the KNX has worked heavily in the past 5 years to extend the protocol with authentication and encryption mechanisms based on AES 128. So products now have the possibilities to also allow the installer to authenticate and to encrypt all data or certain data sent by the device. These extensions to the KNX standard have been already put to international standardization and are part of the EN 50090 series and also a part of EN ISO 22510. I will come to that in a minute. And we have also for the IoT extension, we have also foreseen security mechanisms for that, but I will come to that in the next slide. As for our track record of putting the standard or not keeping the standard as a private standard, so it's not only a KNX or an industry standard, but we also have the good habit of putting results of our standardization into international standardization. So in 2001, we published the first KNX specification 1.0. As a result of that, in 2003, this specification became a European standard EN 50090. This was then in 2004 also brought to ANSI ASHRAE. It's part of the ANSI ASHRAE standard 135, and it's mentioned in Annex H5. In 2006, the European standard, the EN 50090, was converted into an ISO IEC standard 14543-X. This standard was translated into Chinese and became a GBT standard in China 20965. And in 2019, in Australia and New Zealand, KNX became a technical specification. And as I mentioned, data security was made part of the EN 50090 series, and also KNX IP KNX IP Secure became an international standard, an ISO standard with this number. Yes, Casto already mentioned, okay, we are thinking ahead. And we, in the last years, we also, in the last 3 years, we have thought of how can we extend KNX even further into the domain of the IoT. As mentioned by Casto, already from 2007 onwards, we had already the possibility to link to the IP world via KNX Net IP. But it was felt that this KNX Net IP does not solve all problems. And KNX Net IP is, of course, very KNX specific, because what is actually done with KNX Net IP is that the KNX frame is tunneled on top of UDP. So it's still very KNX specific. What some manufacturers said is that instead of tunneling a KNX frame across on top of UDP, what we need to do is we need for at installation level, we need to provide a common manufacturer independent third-party interface. And this third-party interface needs to provide to a third party, as the name says, the KNX data. Not a KNX frame, but just the KNX data. And the KNX data needs to be complemented with rich semantics so that the third party immediately understands, aha, this is a dimming value. Aha, this is a temperature, this is a temperature value. Aha, this is a energy management forecast. So for that, the third-party API was defined. This API is ready. it's already published, and also as a non-member, you can already access to it via the open web page schema.knx.org. As a second extension, we also want to move away from, well, not move away, but more like complement the twisted pair networks, the radio frequency networks, by other networks that are on the rise and that are IPv6 networks like Thread or like the future Wi-Fi extensions that are in the pipeline. So the idea is also that with the KNX IoT Point API extension, there is the possibility to take a thread network and actually speak KNX over thread. So a KNX over thread device could then even talk to a KNX radio frequency device, which already exists today. Also, for that specification, we are heavily working, and we want to complete the specification by the end of the year. A first internally voted document is already available, also via this schema.knx.org. Here you see a summary of what I just mentioned. So for KNX, we want to actually concentrate on what we do best, and that is ensuring interoperability at data level. We want to, for the rest, we want to base on things that exist out there and are standardized already via IETF and other bodies. For instance, we think the time of defining an own application layer protocol is a little bit passé. We base ourselves on CoAP and HTTP, and we only do what is complementary for KNX. All the rest we base on already existing industry standards. What is the advantage of all of that is, of course, for the manufacturers, if they want to make a KNX compatible device, then they have a speedier time to market, because they don't need to design a specific KNX medium solution, if they would like to do that. They don't have to write a KNX stack anymore, or an application layer stack. They can use chips that are already available for that, and just add the KNX specific part to that. Why did I mention semantics before? Because semantics will play an ever more and more important role in the future, because of the building information modeling. Building information modeling shows that because of BIM, a lot of improved reliability is created in the building space, and providing more data is actually an asset. And as I mentioned, for our ETS tool, our ETS tool already works with product descriptions of the different KNX compliant products. So with KNX IoT, we want to enrich this data still with richer semantics, and this will be so the enriching our data with more semantics has two purposes: to provide more data across the third-party API, but also to help the installer the system integrator and the building operator with more data, so that the process of installing and integrating systems becomes even easier than it already is with KNX today. Yes, I want to, for the purpose of energy management, I want to quickly jump to standardization activities in Europe that are currently underway. This is the work of the 5491 part, in which not only KNX is involved, but also other parties are involved. As you can read here in the one but last bullet, also the organization EEBus is involved in this work, and also the Dutch company TNO is involved in this work. So what is the idea of this work? This is to abstract the data exchange between a customer energy manager and so-called resource managers. Resource managers are in themselves, they are abstractions of a particular device, could be a charging station, could be multiple devices, or could be an entire system. It could be an entire KNX system, could be an entire EEBus system, could be an entire whatever system, Zigbee system, or whatever you could think of. So the idea is that these products or this product or these products or these systems can actually tell a customer energy manager what energy flexibility they can offer, so that a central intelligence in the home is able to manage the available energy better. So the standardization is about standardizing this S2 interface and standardizing the application and standardizing the data modeling. It's not about standardizing the protocol that is used for it. This could be KNX, this could be EEBus, this could be whatever protocol you can think of. This standard simply standardizes the data exchange between the SAM and the resource managers. Yes, this again summarizes what I just mentioned. This whole exercise is not about fixing yet another protocol for energy management, but simply laying down different control types for energy management on a European level, and then leaving it up to the market to put a protocol to that. Yes, well, now I come to what does KNX already do as regards charging stations. There are already manufacturers, this is just one example, in KNX that offer interfaces to charging stations. This particular solution supports many different charging station types. You see some logos of the different supported charging station types. It has an integrated Modbus interface. There is no use. There is no need for an extra adapter, and it supports the functions you see over here. So you can show whether a charging station is occupied or it is free on KNX. You can show the charging process. You can set the charging time and limit the charging power. You can report on errors. It allows to report on the car serial number, the charging duration, etc., etc. And also the module in itself already allows you to also do load management tasks directly in the model in the module itself. So integrating of this product is done via the common KNX ETS tool, and it also already supports KNX security. So also the messages sent from onto the KNX bus can be authenticated and encrypted. So if you are a manufacturer and you would like to develop a similar product, or you would even like to go beyond that, there are the following possibilities. So for anybody saying, yes, I do not want to implement the medium, a particular medium of KNX, and I don't want to implement the KNX protocol in itself, there are many certified KNX solutions from different manufacturers. So you can shop around. We don't, KNX does not have an own certified stack. These are offered by our manufacturers. So you can shop around. You can design that all by yourself, if you like. If you want to support IP communication, there are also stacks supporting KNXNet IP, and you simply design your application on top. If you want to support easy installation, then for charging stations, there are no standardized easy channels today, but of course these could be standardized. And if you would like to support these control types of the PREN 5491-12-2, then you can also base your work on the functional block descriptions that are currently under work for these particular control types at KNX. And in the future, also with KNX IoT, you could think of KNX Point API devices sitting on top of HTTP and just exchanging in the KNX way JSON LD data structures to exchange energy management information. So this gives this last slide gives you an overview of how all of that would work together. This is the traditional KNX world, I would call it. Sometimes we refer to it as KNX Classic with TP, with radio frequency and KNXNet IP. So if you would like to send momentary values on energy management, you could still do that with KNXNet IP or KNX Twisted Pair and send them by traditional KNX group messages. But if you would like to send more bulky information, you could do that via KNX Point API over HTTP. And the whole installation would also be, you could also build edge devices, which actually would allow you to also link via the third-party API this installation to a cloud infrastructure or another third-party instance. So in a nutshell, I have put this as a summary of what KNX has to offer. I think the bullets points speak for themselves. KNX can bow over a tradition of 30 years, and we have also a tradition to think out of the box and continuously update our protocol to meet current needs. Thank you very much for your attention. And I can only express the wish that you either join us in the association or on work related to KNX. For any additional information, you could, of course, contact either myself or Casto for any additional questions.